Again, welcome to lecture number 3. Again, welcome to lecture number 3. In this lecture, we are going to cover the rate of change, and also we're going to start with the derivatives. So we're going to get the concept of derivatives. Then in lecture number 4, we will start to apply the derivative formulas. So we know in college algebra, the slope of a straight line is also rate of change. But in calculus, we are not dealing with a straight line. We're dealing with a non-linear function, or a function that is not straight. So we may have another way of finding the rate of change of a non-linear function. Again, the rate of change of a linear function is the slope. It's the same as a slope. That is the difference of y divided by the difference of x when you take 2 points on a straight line. So again, this is rate of change and derivatives. Here we're going to start the basic concept of derivatives. So how do we find the average rate of change of a nonlinear function? And also we're going to define the derivatives as a rate of change. Derivative is as a rate of change. Actually, we always say calculus. The concept of calculus is to finding the rate of change of an object or any entity we can think of. So calculus deals with the rate of change of the concept. So to use definition of derivative to find the derivative of a function, we're also going to use derivative to find slope of a tangent to a curve. So we start with the average rate of change. As I said earlier, for a linear functions, again, we are still on chapter 9 of the course textbook. So average rate of change for a linear function, we have seen that the slope of a line measures the average rate of change of a function. And this can be found from any 2 points on the line. However, for a function that is not linear, the slope between different pairs of points no longer always give the same number. Because we know when a function is a straight line, the rate of change is the same. Take any 2 points, you get the same, which is the slope. But with nonlinear, taking 2 points on a nonlinear function to find the rate of change always will be different, because the function can be decreasing or increasing, or the steepness will be high or low. So that is the concept here. So in this case, we have to use a formula. So this is average rate of change formula. We can see this is a non-linear function. Again, if it's a linear function, we can just take a 2 points and find the difference of y and x divided by x. But when we are looking for average rate of change of a function, the function is given as f at x, and the rate of change is from the interval a to b. Then we say the average rate of change will be f at b minus f at a divided by b minus a. Again, the interval, this graph here we see from a to b. So we are looking for the average rate of change from a to b. So it will be the function at b minus the function at a divided by the difference of the interval b minus a. And this is what we term by average rate of a change of a nonlinear function. So let's start with an example here. In example here, we have a figure from the US Department of Commerce. And here they are giving us the data or a graph by the men and women in the labor force or the workforce. So we can see that in 1970, we have 9.7. This will be in millions, and 26.8 for men. 1980, we have 8.1, 19.0. So men are blue and women are pink. Now we can find the average rate of change of a workforce for male between 1990 to 2000. So which means 1990 to 2000. I will look for the 17.7 is 2000, 16.3. So I'm going to find the difference of 17.7 and 16.3 divided by the difference of the year 2000 minus 1990. And that's how we're going to do to find any average rate of change from one particular year to other year, either on men or women and the workforce. So here they say we should find and also interpret the average rate of change of the percent of A, elderly men in the workforce, and B, elderly women in the workforce from 1970 to 2040. So 1970 is here and 2040 is here. So for men, it will be 17.3 and 26.8. 17.3 minus 26.8 divided by 2040 minus 1970. Here we're going to say that our answer will be negative because there's a decrease. In 1970, we have more elderly women, men in workforce than elderly men in 2040. In the women, since we have increasing, 1970 was 2.7 elderly women, and 2040 is 10.1 elderly women. So let's see the calculation next slide. So we are looking for the change in men's percent. So as we said earlier, this will be negative answer because 17.3 was in 2040 minus 26.8 was 1970. So finding the difference, we get negative 9.5 divided by 70. And that will give us negative 0.136. This value, 17.3 and 26.8, is given percentage. So our answer will be negative 0.136 percentage points per year. So this means that from 1970 to 2040, on average, the percent of elderly men in the workforce dropped by 0.136 percent points per year. Again, drop. Why? Because the our answer is negative. If our answer is positive, then we say increase. Now, with the women, we look at the 2040, it was 10.1. 1970, it was 9.7. So we find a difference of 10.1 and 9.7 divided by 2040 minus 1970. And that gives us a positive value. So there was an increase. So in average, we have increase of 0.0057 percentage points per year for the elderly women in workforce. So here, the concept here is how to find the average rate of change. So here we know the difference, which is almost like a slope. The difference of, let's say, y divided by the difference of x. X is our years, y is our percentage points from the graph. We also have what we call the instantaneous rate of change. Remember, the rate of change was an interval, a period of time. There's a difference here now. Here we have instantaneous rate of change. We talk about a particular time. But rate of change is a period of time, an interval. So let's go through this. They say here, if we represent the change in time by h, then the average velocity from 1 to 1 plus h approaches the instantaneous velocity at s equal to 1 as s approaches 0. We should know that h can be positive or negative. Now we will see an example. So the concept of velocity, suppose that a ball is thrown straight upward so that its height f at x in feet is given as following. So f at x, 96 plus 4x, 64x minus 16x squared. This is the height that the ball is thrown to. And x will be the time in seconds. Now the question says we should find the average velocity from 1 to 1 plus h. This will be the rate of change. Then secondly, we're going to find the instantaneous velocity at s equal to 1. So this is what I'm saying, that average rate of change is always in a period of time, but instantaneous velocity or instantaneous rate of change is at a particular point of time. So we see here they say find the average velocity from x equal to 1 to x equal to 1 plus h. And also find the instantaneous velocity at s equal to 1. So let's see this example. Now we have the concept of the formula already. So here we say let h represent a change in x time from 1 to 1 plus h. Then the corresponding change in f at x height is what? Remember, we have the formula to be, let's go back to the formula one more time. Again, this is the function given to us, 96 plus 64x minus 16x squared. And we know the formula also, average rate of change will be f at b minus f at a over b minus a. Now, in this case, a will be 1, b will be 1 plus h. So that's why here we have what? F at 1 plus h, which is f at b, minus f at 1, which is a. So we solve the numerator first. Then the denominator will be 1 plus h minus 1, which will give us h. So here we know anywhere we see, since this is 1 plus h, anywhere we see s, we represent it with 1 plus h. Then the second part, anywhere we see x, we represent it with 1. So we know we have 96 plus 64x, so now it becomes 64, 1 plus h. Minus 16s squared, now s squared becomes 1 plus h squared. So everything here is only for f at 1 plus h. Anywhere we see s, we substitute it with 1 plus h. Now minus the second part, which is f at 1. So anywhere I see x, I'm going to substitute it with 1. So I have 96 plus 64x, it will be 64 times 1. Minus 16s squared, it will be 16 times 1 squared, which will be 16 and 16. So now we simplify this equation. We were able to remove the parentheses here. We get 96 plus 64 plus 64h minus 16 and plus, again, this is a perfect square. 1 plus h is the same as 1 plus 2h plus h square. College algebra perfect square. A plus b square is the same as a square plus 2ab plus b square. And that's what we have here. 1 is 1 square plus 2, 1h. 2 times 1 is 2 times h is 2h plus h square. So we simplify all this. 96 plus 64 minus 60 will give me 144. So the next step now is to remove the parentheses here. So we get minus 16 minus 32h minus 16h squared. And that's what we have here with the 96, 64. Simple. We find the differences simply. So here, after we do all the simplification, we get 32h minus 6h, 16h squared. Then we move next step. Remember the formula we said is what? Average rate of change will be f at b minus f at a over b minus a. So we already find f at 1 plus h minus f at 1, which is f at b minus. That's our solution. Now we say we divide by what? B minus a. B is what? 1 plus h minus what? A is 1. So this will give us only h. So we substitute our solution we have for f at 1 plus h minus f at 1 to be 32h minus 16h squared. Here we can factorize it. We take the h out, we get 32 minus 16h, and the h will divide by h here, so the h cancel. So finally we get 32 minus 16h. And if h approaching 0, the answer will be 32, as we said, based on the question. Why h approaching 0? Because let me read the question one more time. We suppose we throw a ball is thrown straight upward so that its height is given by the following. Since we are not moving, excuse me, h will be 0, approach 0, because the ball is thrown upward and then downward. Now, one thing I will mention here is that you see our answer. This is what we are going to do, and actually that's what I want to even mention. You see, our answer was 32 minus 16h as h approaches 0 because it's 12. Our answer is 32 feet per second. This solution is the same as derivative. Now, if I want to find the derivative of this function, I will get 96 plus 96 of a constant is 0, 64 minus 32x. And again, we're going to talk about this, how the formula came about, but let's just keep going. We're almost done. So this is our solution, as we said, 32 feet. The reason why, because h approaches 0. So our final answer is 32 feet per second. Now, they say we should note the average velocity is found over a time interval. That's what I mentioned before. But instantaneous velocity is always called velocity, can be found at any time x as follows. So suppose that an object moving in a straight line has its position y at time s given by y equal to f at x. Then the velocity function for the object at time s is what? The limit h approaches 0, f at s plus h minus f at x over h, provided that the limit exists. H approaches 0 exists. So this is the formula we are always going to use to find a derivative of a function, because the rate of change, velocity. Now, the instantaneous rate of change of any given function, which we commonly call the rate of change, can be found in the same way we find velocity, the same. The function that gives this instantaneous rate of change function is called the derivative of f. And that is the function here. So f at s plus h minus f at x over h. Again, f at s plus h minus f at x over h. And we're going to see an example here. So to find the derivative of y equal to f at s at any value x, first we let h represent the change in x from x to s plus h. The corresponding change in y equal to f at s is given as f at s plus h minus f at x. Now we have to form s plus h minus f at s over h. Then we can determine the derivative. Now we will see a questions, homework assignment. If they say we should find, next lecture we are going to learn how to use the derivative formula to find the derivative of a function. Different formula, the power constant. At the moment, a question may be given, find the derivative of this function, f at s equal to 3s squared plus 2, using the limiting process. Now, when they say using the limiting process, then we have to use this formula. Otherwise, we can also use the derivative formula. Now, when we plug in the value, this is the long process we can see here. Now, for example, let me explain this very simple. This is an example now. Find the derivative of f at x equal to 4s squared. If I'm using the formula, this is a power rule. It means I have 2 here, so I'll multiply 2 by the 4, which will be 8. Then I'll subtract 1 from 2. So actually, my answer here will be 8x. And you can see, again, I'm using the formula, power rule formula. Multiply the expression by the exponent, then subtract 1 from the exponent. So we get 8x. But look, if I follow the process, the limiting process, the formula given to us here, which we use here, we will get the same answer, 8x. But it took me less than 1 second to just tell the answer. I mean, 2-3 seconds, if I know the formula, the rules. So let's go through this step. Again, we're going to study the formulas next class. So example is given to us, f at s equal to 4s squared. Our goal is find the derivative of this function. We use the formula f at s plus h minus f at x over h. So the change in x from x to s plus h is h. Now the change in f at x is f at s plus h minus f at s, almost from the average rate of change. So this means First, I have 4x squared. So anywhere I see x squared, I'll put s plus h squared. Then minus, here I have f at x, so it's the same thing. So I'll put minus 4x squared. Now, when I simplify this, perfect square s plus h will give me s squared plus 2sh plus h squared. Then minus 4s squared with the 4. So I open the parentheses, I'll get 4s squared plus 8sh plus 4h squared minus 4s squared. We can see that minus 4s squared and plus 4s squared will cancel. So our final solution here will be 8sh plus 4h squared. Now, remember, this is only for f at x plus h minus f at x. Now, we have the formula say divided by h also. So we have to divide our solution by h. Now we get 8x plus 4h. Now, since the limit h always approaches 0, we will get 4 times 0 here. So that will give me 0. So my final answer will be, again, 8x. Okay, so instantaneous rate of change velocity, as we said earlier, finding it at a particular point. So here they say the derivative at any point x may be denoted by dy dx. Some books use dy dx. We saw the example here, they use the f apostrophe or dds f at s, or capital letter dx, or sometimes y or dx f at x. Also, sometimes we may have a question, they will say find the marginal revenue. When they say we should find the marginal revenue, marginal cost, or marginal profit, what they mean is that we have to find the derivative of that very revenue or cost or profit. Because marginal revenue for a product as the rate of change of a total revenue function for the product. So it's a rate of change. And we can see we are using the same formula. Rs plus H minus Rs, using the limiting process. So a question is given here. Suppose that an oil company revenue in thousands of dollars is given by the equation Rx equal to 100x minus s squared when s is greater than or equal to 0, where x is the number of thousands of barrels of oil sold each day. Question says, find a function that gives the marginal revenue at any value of x. So we have to find the derivative. Now, next lecture, if I'm finding the derivative of this function, I'll use the power rule here and multiplication. So the answer will be 100 minus 2x. But we can plug these values using the limiting process formula of f s plus h minus f at x divided by h, and we get the same answer. After we get the marginal revenue equation, they say we should find the marginal revenue value, the actual revenue, when we produce or sold 20,000 barrels. So this means S is equal to 20. Why 20? Because we said X is in thousands of barrels, number of thousands. So here, first of all, again, we are not going to use a formula here. We're using the limiting process. So we find the derivative of R, which is the revenue, marginal revenue. We know we have 100x, so S becomes S plus H minus S squared, so it will be S plus H squared. Rs is the same as the equation, original equation, so it will be 100x minus x squared, all divided by h. Then we remove the parentheses, 100x plus 100h. Perfect square is here, so this gives me s squared plus 2sh plus h squared. And later we can remove the last. So when we simplify everything, we get 100h minus 2sh minus h squared and h. H is common for everything, so we take the h out. Then we get 100 minus 2s minus h. As h approaches 0, our answer will be 100 minus 2x. And that's what I was saying the earlier time, that using the 100x is a multiplication constant with variable. The answer will be 100. X squared will be 2x. So we get 100 minus 2x if we know the formula. So the marginal revenue function is given as following. Now B, I will replace X with 20, which stands for 20,000 barrels. And our actual revenue to be 60,000. The answer is 60, but it's in thousands, so 60,000. Now we say because the marginal revenue is used to approximate the revenue from the sale of one additional unit, we can interpret R derivative of at 20 is 60 to mean that the expected revenue, so it's like average, the expected revenue from the sale of next 1,000 barrels will be approximately $60,000. Now the actual revenue from this sale is 59,000. So the next is the tangent to a curve. In geometry, we say a tangent to a circle is defined as a line that has only one point. So when you look at this line on a circle, it has only one point with a circle. And this line is called a tangent line because it's a straight line that go through a circle edges and have only one point on it. Now in this figure here, we say the line L can represent the tangent to the curve at point A and shows that the second lines S1, S2, etc. through A lines is a second point also Q1, Q2 approaches A. And we know this from a limiting process. So we see that the slope of arbitrary second line through A, X1, F at S1, Q, this is our 2 points, A to Q, is given as the limiting process formula. So the slope of a tangent line is the same as finding the derivative. So the slope of a tangent line, the straight line on the circle with only one point is F at S1 plus H minus F at S1 over H. So given the following example, y equal to f at x, which gives us 3s squared plus 2s plus, find the derivative of f at s at any given point s and fx. Now, if I want to find this derivative, the answer will be 2 times 3 is 6. 2 minus 1 is 1, so 6x plus 2. The answer is 6x plus 2 if I'm using the derivative formula. But here we're going to use the limiting process, so it's a little bit long process. We use the f at s plus h minus f at s over h. We will see that we will get the same 6s plus 2. So we plug in the value. Anyway, I see x, I will substitute it with s plus h squared. S plus h. Then here we have the actual minus f at x. So it will be f at x, 3s squared plus 2s plus 1. That's the original function. So we simplify it, perfect square, we get s squared plus 2sh plus h squared. And we multiply 2s plus 2h plus 11 minus 3s squared minus 2x minus, so this is negative, so all the sign will change. Now from here we can see if we can be able to cancel something and do combine, etc. So when we do everything, we get 6sh plus 3h squared plus 2h over 2. So this will give us h outside. So we get 6s plus 3h plus 2. And that h outside will cancel the h at the denominator. And since h approaching 0, we say 3h will be 0. So as we said earlier, the answer will be 6s plus 2. And the derivative of f at s is 6s plus 2. Now, second part, we know the value of x and y, 1 and 16. So we substitute 1. And 6 times 1 plus 2 give me 8. The equation of the tangent line uses a given point, 1 and 16, and the slope is 8. So we can get y equal to 8x plus 8 because we use the slope formula. Y minus y1 equal to ms minus s1. The derivative of a function has several interpretations. This is very important. This is what we just now. If I want to find the derivative of a function, it's the same as looking for velocity. But the velocity is for what? An object moving in a straight line. So if you have a question, the question say, okay, a so equation is given, find the velocity of an object moving in a straight line, or find the instantaneous rate of change of a function, or find the marginal revenue for a given revenue function, which is again derivative. Slope of a tangent is also derivative. So these four type of questions always means we find the derivative of their functions. And most graphing calculators have the features for numerical derivative, which is NDEL or NDeriv. So again, that will be the conclusion of lecture number 3. Here we learn again the basic concept about derivative, which is a rate of change. Then we saw the rate of change formula. We saw the instantaneous rate of change formula, and also how to find the derivative, again, using the limiting process. When I say limiting process, I mean using the formula f at x plus h minus f at x divided by h. Next lecture, we are going to start to learn the derivative formulas and their regulations. So again, thank you very much. You can comment on this video, or if you like it, or you can also subscribe it. And this video will be posted in the YouTube. Thank you.